Now we're going to turn our attention to combinations for a little bit, and different books use different notations. Sometimes we use NCR, sometimes we use this parentheses with two numbers in them. Basically, this is a combination of n objects taken r at a time. And if we use the formula here, we will find out that 52 choose 5, that's what we call it sometimes, is equal to 52 factorial divided by 5 factorial times the difference of these two, which is 47 factorial. And we could multiply that out on our calculator if we wanted to get 2,598,960. Okay, let's talk about our calculator here. Some of us are going to use the NCR button on our calculator. And if you're using the NCR button, then you're probably going to type the 52 first, followed by the NCR, followed by 5, and then the equal sign. If you have a C of n comma r button on your calculator, you are going to hit that C of n comma r button first, then type your 52, then hit your comma key on your calculator, 5, and then equal after it to get that 2,598,960 value. In this next exercise, they want to show us the connection between combinations and Pascal's triangle. In this first case, we would have 5 factorial divided by 0 factorial and 5 factorial, which is equal to 1. In the second problem, we would have 5 factorial over 1 factorial 4 factorial, which is equal to 5. In the next case, 5 factorial over 2 factorial 3 factorial, which is 10. And then 5 factorial divided by 3 factorial 2 factorial, which is also 10. Followed by two more numbers, 5 factorial over 4 factorial 1 factorial, which is 5. And then 5 factorial over 5 factorial times 0 factorial, which is 1. These coefficients are 1, 5, 10, 10, 5, 1. And if you go back to Pascal's triangle here, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Basically, we are saying that we can represent each row of Pascal's triangle using these combinations for these binomial coefficients.